Greetings, the Astro 30 here yet again with another fun-filled episode looking at this audio sound reproduction device, aka the 15W plus 15W stereo amplifier project. I am going to say that it has been a journey with this particular project with having to redo the preamplifier. And now, I've shot this piece of video before I've actually received the new preamp and actually tested it, so I'm not going to say that I've solved that problem yet. We're going to look at the input switching circuitry. So I can switch up to 4 inputs here, stereo inputs, left and right. It uses 4 small relays which are available from JCar. Online it says check store stock, so it's getting to the point where that's probably going to be another product that JCar are going to remove. But if you cross-reference the catalog number SY4059, I believe it is, in Google, I'm sure you'll find another supplier of it. So the relays use all the normally open contacts for the inputs, and the center posts are connected on either side of the DVDT relay to either the left or the right output respectively. So it's a pretty simple relay switching circuit. There's not much to it. And down here we've got a bunch of driver transistors coming off of our S-control connector here, which connects back to the preamp's S-control connector. Now the reason I'm using transistors is because I want to isolate, for want of a better term, the relay coils directly from the regulator. The transistor is the device that's doing all the current handling for the relay, which is about 40 mA or something. And also if this flyback diode here, or any of these flyback diodes here, fail, I'd rather that the back EMF from the relay coil goes through the transistor or transistors rather than through the regulator. So the task today is to test this circuit out, just one relay driver. Not too worried about the input switching circuitry over here. I know that's going to work, there's nothing to that. All I know is the transistor that I've chosen, which is a BC549, is capable of driving said relays. I chose BC549 because, well, I've got 6 of them that I pulled off the first transistor preamplifier, and they're now sitting in a container somewhere unused. So I might as well find a use for at least 4 of them. And I also want to make sure that this 10K base resistor here, current limiting resistor, is high enough so that we're not oversaturating the transistor to the point where it can overheat and fail. So we'll have a look at the CAD drawing for the PCB in just a moment. So here is the PCB layout in KiCad for the input selector, and I've got the input selector connector for the control wires on one side of the PCB, and the output is over on the other side of the PCB. This is our audio ground path, and this is our DC or switch ground path. So I've separated the earths, or grounds, so we should have very little clicks and pops when every relay engages or disengages respectively. Should. That's the idea anyway. And that's the 3D rendering of it. I mean, it's not much to look at because, well, I had to come up with my own footprints for the relays. As usual, KiCad doesn't have one for the particular relay I wanted. So I had to painstakingly create one in the component editor. That's why there's no 3D box or model for it. But yeah, that's what it's going to look like when it's finished. Not exactly that color, but I've designed it to use PCB mount RCA sockets, which I will show you in just a moment. So let's get on to talking about the RCA sockets and testing the actual relay driver. And here are my RCA sockets. I bought these off eBay, and these are what are known as a 4-pole or 2x2. They do make an 8-pole, but of course the listing I was looking at and all the other listings on eBay similar to this were all out of stock. So I could only get the 4 poles. But that's fine. I mean, when they're lined up on the board like that, the 8-pole will fit in its position just quite nicely. So there's a choice of using the 8-pole or 2 4-poles. You can probably find these listed on Mouser if you really want to troll it, and probably even DigiKey. But there is a listing on AliExpress for these as well, so there's plenty of places and suppliers where you can get these from, I should say. So those are the RCA sockets that I'm going to use. They're very cheap. I think I only paid about $3 each, maybe, for each one of these. Something like about $1.90 or something US. They're not very expensive, and the quality of them does look very cheap. But anyway, that's the RCA sockets, and these are my relays. I bought these from JCar, but it does say on their website to check store stock, so these may be one of those other products that are soon to become discontinued from JCar like everything else. But if you cross-reference the catalogue number, which is SY4059, I believe, in Google, for instance, I'm pretty sure you can find another supplier of these elsewhere. And I'm pretty sure you can buy a similar relay on Alltronics, AliExpress, and even Mouser and DigiKey. So there'll be places where you can buy these. These are Panasonic relays. Well, it doesn't actually say Panasonic on them. So what I need to do is I need to take one of these relays, and I want to verify that my normally open, common, and normally closed switches are in the right positions compared to how they're routed on the PCB, because there's nothing worse than having the PCB manufactured, then come to realise that the switch is wired incorrectly, and you either have no output when the relay is on or an output when the relay is off. Either way is completely wrong. So that's why I'm going to breadboard up the driver circuit. I'll just solder a couple of wires to the coil on a piece of breadboard, and just connect a multimeter across where I think the common and the normally open position is, and then drive the relay on and see if the multimeter makes a beep. So let's get that done now. Okay, got the circuit built up. This is my trigger resistor right here, which is a 10K resistor. All I've got to do is then touch that to where the cathode of that diode is up there, which is our back EMF diode for the relay coil, which connects to the positive rail. I've got the multimeter there in continuity mode across what I believe is the center pole of the DBDT switch, which is the red wire, which is at the bottom just nearest the coil, and where the normally open position is. And obviously there's no beep at the moment. If I was to move that to the center pin, it would beep. So now all I'll do is I will connect up the 10K to the positive rail. Bingo. Perfect. And we've got about nearly 0 ohms there. If I move that to shut it up to there, where it'd be normally closed, nothing happens. But so far, the relay is being driven by the transistor, and I can't feel the transistor heating up too much, which is a good sign. It seems fine to me, so that's good. We're at 12.1 volt and drawing NAFL current, but I don't trust that current meter anyway because I don't think it's very accurate. If I was to put the multimeter in current mode, in milliamp mode at least, across the positive supply, we could find out how much the circuit is actually drawing. Anyhow, if I was to now just double check this transistor, nope, it's fine. If I was to disconnect this, there we go, now we've got continuity, so I know that in my final PCB routing, it's routed correctly for that relay. So I can go ahead and have that manufactured, and I know that the relay itself, the driver, works fine with a BC549 and pulls the relay in fine, and it's not overheating the transistor at all. So as I said, if I was to put my multimeter in current mode, and fart and change where the lead is connected, and I remove, that stunk, I remove the positive supply lead from the circuit and then put it across the positive rail. 17 milliamps. That is bugger all current. That's quite good actually. I'm quite surprised, because I thought these relays were at least 30 to 40 mA, but according to this it's only like less than 18. I could actually look at what the resistance of this coil is, and then I can actually calculate from the voltage what the current should be. And currently the voltage at the relay is roughly 12.1 volts, so that's what's going to the relay. As to what's coming into the circuit, if I move this to the ground now, 12.17. We haven't got much of a loss, probably about 70 millivolts or so. Yeah, it's not much, maybe 100 millivolts. Okay, so now I need to work out what the resistance of the coil is. Well, at least I got the catalogue number right. It is SY4059. And it says check store stock. Now, the coil resistance according to this is 360 ohms. And it does not give me the current. Alright, so we know that the coil resistance is 360 ohms, which would make it 12 volt divided by 360. Well, it's supposed to be around about the 33 mA mark, but according to my multimeter we're only drawing 17. So that means that in total with the input selector relay plus the LED, which is around about 15 mA we'll say, if we've got like 17 mA plus 0.0, we'll say 15, that's a total current draw on that TO92 style 78L12 regulator IC of 32 mA. And they're only rated at 100, so we're under half of the current capability of that said regulator. So excellent. I'm happy to see that the current draw is very limited. And there goes the relay. And that nothing gets overly hot. The transistor is nice and cold. It may have been getting slightly warm. The coil itself was not getting hot, so the circuit should work fine. So the way I've got it routed on the PCB is perfectly fine with those current values. So I can go ahead and have that circuit made.
One eternity later.
Well, my PCBs for my input selector and a couple of other things have arrived just now. So we'll open the new box. I love opening PCB boxes, as you all know. Alright, what have we got here? Oh, I don't need that piece. They're all stapled together, so I'll just get them all out of the box. Dispose of the box. And starting on the top, this is the new switch adapter that connects the switch at the front panel to the mains cord, etc. As I described in the previous video on this project, this is the headphone adapter board, which I'm still in two minds about adding, but we'll do a separate video on this because I'm not going to include it in this one. And there is my input selector boards. So I need to open the packet once I find out what I did with my knife. Bubble wrap's not as compressed around the PCBs as it usually is, so I don't know if there's an issue with their vacuum pack machine, or there seems to be a little bit of air in there. Sorry folks, I seem to be having a bad day today. Been pretty much like that all week actually. Here we go, there's one of them, I don't need all of them. So this is the input selector board, which actually turned out a little bit smaller than I thought. But one point of interest, over this side we've got the V plus, ground, A, B, C, D connections here. And I've marked above each relay what that relates to. So position A over here is for this relay, which is marked A, B, C and D respectively. So the first things first I want to know is whether the footprint I made for the relay is going to fit. Like a glove. Okay, that's one issue solved. And my RCA sockets is going to fit. Now if I did my mathematics correctly when I designed the board, it will, but it doesn't quite look like it does. My math is way out on that. That's slightly annoying. These plastic tabs aren't going to fit through the provided holes in the board, so that makes it kind of difficult now. Yeah, there's no way that's going to fit. It's not even going to fit through the holes. Unfortunately, I'm going to have to do the one thing I didn't want to do and defeat these tabs. It's the only way it's going to fit in there. It's kind of a shame, kind of annoying. My measurements were just wrong. Which is okay, they're only little plastic tabs. It's not the end of the world. The pin spacing looks right though. If I can get the stupid thing to go in there. There we go. The actual alignment of the mounting face is flush with the edge of the board, so it's not going to be like inset a bit causing a problem, so it's still going to work. So that's the way I'm going to do it. It was unfortunate that I had to defeat the little plastic tabs. I'm going to trim them down a bit further because they're sitting up a little bit of an angle. And just go with it like that. It's a shame, but it is what it is. Okay, so I've cut them down flush now. It shouldn't be an issue. If I'm concerned about mechanical strength between this part and the board, I can always run a dab of hot glue around the plastic and the PCB here just to, you know, make it more rigid, which is probably what I'm going to do. Everything else will fit fine, so what I'm going to do is I'm going to start assembling this PCB. Okay, the 4 resistors and 4 diodes are installed now. Now I'm going to move on to the connectors because that's the next tallest components. Then I'll do the transistors, the relays, and then finally the sockets in that order. There's the transistors and the connectors installed. I repurposed the BC549s I pulled off of the original preamp PCB before I changed them. There's nothing wrong with them, so might as well reuse them. So now I can do the next largest height component, which is each relay. So I'll just start with one at a time because, well, it's easier that way. Oops, I just filled in a hole by accident. It's alright. You don't need to put a lot of heat into this because actually several holes have been filled in now. There are only like small relays, they're only thin and you'll melt the plastic, so there's no need to like put a hell of a lot of heat into it just to solder it. So I'll just clear out these holes that I accidentally filled in, if it so wants to. Solder wick is a great invention, I must admit. Alright, so that's fixed that problem. Now I can install my final component, or components because there's 2 of them. This board should only take about 15 minutes to put together. It's not that complicated. It's a shame about those holes. I can't use the clips that came with the RCA sockets, but yeah, it's fine. Really should have mounted this in something because I'm chasing it around the desk right now, which is annoying, but we get there. Now, only thing left to do is to test it after I've finished. Just make sure that one's soldered properly. That's the soldering complete. I don't have to do anything else now except test it. So I just want to make sure that my distances between these 2 points are 14 roughly, thereabouts. Yeah, my hole centers is still roughly about 14. I mean, I can massage the sockets back and forth just to, you know, get them to be at 14. But once the hole's drilled, it should be fine. Right, so what I need to do now is I need to hook this up to the control board or the preamp of the amplifier. I'm not going to worry too much about the output at this stage. What I want to do is I want to test the functionality of each of these relays. I want to test the functionality of my crimp connections, make sure that they're not loose, because once I do these light tight connectors I like to wiggle the wires around whilst it's on to see if anything drops in and out. And then I want to see if each input's being switched correctly and appears at the output. So what I'm going to have to do is set up a bit of equipment, but not too much because I'm not going to get too involved with this. Alright, I got it hooked up to the amplifier via this cable here, which I made last night or the other night. Now I'll turn it on and I'll be quiet. I want to listen to see if I can hear a relay click over here. Well, I didn't hear anything. I still don't hear anything. Alright, so I've got my multimeter set up. I need to find the ground connection, which is there for the switch ground, and I need to measure the voltage coming in. I've got 12 volt DC coming in, so I know that that one's functioning. I've got 12 volt DC coming into the A part connection, which should be coming through, excuse me, a relay. I mean a resistor. There's the voltage there through that 10k resistor, which is going into there. I've got 0.7 of a volt, which is enough to turn the transistor on. And it's going to the transistor, and with respect to the positive rail, I have got 11 volts there. The relay should turn on. Why is it not? Right, so the cathode of my diode over here is connected to the positive rail where it should do. That should also be connected. Yes, yes, yes. So I've got connectivity from the positive side of the relays to the positive of the circuit. I've got 11 odd volt coming out of the transistor, so that relay should have turned on, but I just don't hear anything. I found the issue. These relays have an internal diode. And of course the anode is over here where the cathode or the normal diode is, so it's never going to work. I just tested it with a power supply. I moved the diode out of circuit, and yeah, it's clicking in the reverse polarity direction. You lose! Alright, so unfortunately I can't use this board in its present condition, not with these relays anyway. The relays are proving difficult to get back off, but I managed to reclaim the RCA sockets at least, and I've tested them, they still work. I was looking on Alltronics. JK are pretty much useless for various relays now. So I was looking on Alltronics and I did manage to find S4150, which is a 12 volt micro 1 amp PC DP/DT relay. That's the supplier order code. Now the features are, you know, the same. I cannot see anything in here about a diode, and if we look down here, well, here's the bottom view of the pinouts. The footprint's exactly the same as I'm using on my current PCB. The measurements, like its width and its depth, is the same. The height's not really relevant. So I cannot see anything in this data sheet that denotes that it's got a diode. So I've ordered 4 new relays from Alltronics, and they should be here sometime next week, which is a bit faster than trying to get it from China. So I may hold off uploading this video till then, when I've got the new relays, and I'll build another board up, and well, I'll test the relays out of circuit first to make sure that you can connect the supply up either way around. Knowing that, I'll make my changes in my assembly information document to not use these relays, because the actual part number on it, we ignore this part. It's this number over here at the very top right hand corner, as looking at it this way. There's a D on the end, and according to the datasheet for this particular relay, the D denotes an internal diode, and we can verify that. So on RS Components website, there is the relay that I'm using, and we can even clearly see, regardless of what the numbers are, there is a D at the end of that code. So right away in the text of the datasheet, and this is looking at the release time, the nominal coil voltage applied to the coil excluding contact bounce time without diode. So there is actually two versions of this relay. So if we look at the pin out information for the DS2 form C factor, which is what this relay is, we can see here clearly that pin 16 is marked as negative and pin 1 is marked as positive. So there is actually a diode across this coil. However, I didn't realize this when I was writing the PCB, so I made a mistake. Yeah, and obviously my positive, because this is looking at the bottom view, by the way, so if you were to flip it over, the positive would be over here, or pin 1 would be over here on the top, well, top right, and the negative would be on the bottom right. So yeah, it's reverse polarity in the circuit basically is what I'm trying to say. So that is kind of annoying. This is a different version of the relay. This looks like it's a latching condition, maybe. Yeah, 2-coil latching, and they're also polarized. I don't know why Panasonic did that. Maybe they were trying to limit the component count on their PCBs when they were using these relays in things, but it's just annoying. I didn't realize that. I didn't test properly for that when I was testing it up on breadboard. I didn't try reversing the connection just to make sure. So I've spent $36 and I've ordered, which is $36 I didn't need to spend, by the way, and I've ordered 4 new relays from Ultronics, which takes me over the $20 minimum delivery cost, because they're about $5.75 each, and they should be here by Wednesday next week, so I can make up a new board. I've just got to buy new transistors because I don't have enough. So that's where I'm at with this thing. I'm not worried about the JST connectors. I've got plenty of them. I've got plenty of replacement diodes. I've got plenty of 10k resistors, so I just need to buy 4 new diodes, transistors I should say, and just build the board. I've already taken the RCA sockets off, as I said. That was a lot less painless than trying to remove the relays. Even if I wanted to spend the time, I could probably remove the relays, but the likelihood of me damaging the relays, taking them off, or breaking either the relay body or the PCB even, is pretty high, being plated through hole. If it was just single-sided, it wouldn't be so much of an issue. But as I say, it is what it is. So this board is savable, but just not with these relays, with the D marking denoting at the end of their I think that's a manufacturing date code or something, but the D means diode. So I'll have to update my documentation to say, even though the parts list says this particular relay, not to use it, and I'll put a link to the Ultronics version instead. And I'm pretty sure that'll solve the problem, and that'll work a lot better than what I'm trying to do. So yeah, I might hold off on uploading this video till after I've got the new relays next week. Now we'll move on with something else in the meantime, and I'm going to look at the new switchboard, or switch adapter board. So it's the same layout as the original one. We've got the active and the neutral line voltage coming in here. I've changed this warning to mains voltage rather than 240 volts, because if you're in a different country with 120 volts, it's not 240, is it? The switch In and out spade terminals are still in the same place. I've included my sprite. The only difference now is the capacitor has been rotated around 90 degrees and is going across the active and the neutral after the switch. I've included two terminals here, spade terminal connections for the active and neutral outputs to the transformer, and a large header connector. Now you use either one or the other, not both, not unless you're powering two transformers, because the last thing you want is a connector with exposed metal parts sticking out that you can accidentally stick your finger on it when it's live. So choose one or the other, not both. So I'll get this assembled up and we'll get it in the case and do some tests on a dim bulb just to make sure it's not going to blow the shit out of the power supply of the mains, and which it shouldn't. Alright, I've got the new switchboard adapter built. I just reclaimed the parts off of the old one. I still had the capacitor. Now, I'm about ready to test it in the amplifier. I've had these capacitors across both active and neutral on the switch before. It doesn't do any harm to anything. I've got the connector here to go to the transformer, but there's options here for two spade terminals, but you don't use both. And quite frankly, it's going to be a real tight fit anyway to have both on there. Okay, so now I'm going to put this back in the amplifier, hook it up, put a dim bulb on it, and test that it works. Because if it doesn't, we're going to have a real problem. Plus gravity is starting to piss me off because everything keeps falling on the floor. Right, the main switch on the amplifier is off. Dim bulb's off. Turn it on. Nothing unusual. Turn the switch on. Dim glow and then bug it off. Seems to be working fine. Alright, so I've got it plugged directly into the mains now. Turn it on. Nothing unusual. Excellent. It's working fine. Sweet. I also forgot to mention that I've put in the new LED display board with different LEDs and a 47k drop-in resistor, and now it's not overly bright. Alright, so now we can move back on to the input selector. Well, that was actually reasonably fast. These are the relays from Ultronics. I ordered them Friday afternoon. It's only Monday morning, so it got here relatively quick, and it's probably the quickest order I've ever got from Ultronics. Anyway, I've got them now. I'm going to test them on a power supply just to make sure you can have the polarity either way around. There's the code for the relay, their catalog number, S4150. And they're about $5 and I think it was 70 cents each. I'll have to look at the invoice and give you a better figure. Now, I'm feeling a little bit under the weather today, so I'm not going to do too much to this, but I am going to test these relays. Now, conveniently, the power supply is still set around about 10 volts, which should be enough. I can hear it clicking that way, so I'll swap the polarity. It's clicking that way. Those relays do not have an internal diode. Isn't that sweet? Okay, so that was well worth the $32 I paid to have them shipped relatively quickly. So, let me just find out what the cost of these relays actually are. Yes, I was right. $5.70 including GST. Total GST is $10 on all the items, so that gives it $22.80 plus the $10 for freight, which gives us a grand total of $32.80, including a GST of about $2.98. Okay, so I'm happy because that board now is savable because I've got working relays. All I've got to do now is just solder them onto the new PCB, which is sitting there. These aren't soldered in yet. I've made up a new PCB with new components. Oops. And yeah, so all I've got to do is solder them on the board. The pin out should be the same. I can verify that with a multimeter just to make sure. that the connections aren't reversed on the normally open, normally closed in center, etc. Now, as messy as that is, I've got one lead of my multimeter connected to the pin that's closest to the coil, this other one on the outside pin, which should be the normally open, and I've got this pen sitting between the two power wires that connect to the relay so they don't short. So I'll turn the supply on. Bingo. That is, shut up, thank you. That's how it's supposed to work. Okay, let's get them on the board. And before I do that, I should really clarify the numbers on here, because the website just shows 1 amp 12 volt on the picture. These are actually an M4 12H, and 1 amp 20 volt DC, 24 volt DC. Are these 24 volt relays? Well, that can't be right. I reckon that's 1 amp at 24 volts DC going through the contacts, but these should be a 12 volt relay. But anyway, that's the number anyway. It's an M4 12H. And there's the completed PCB for the most part, except for the RCA sockets. Now, I've left them off for a reason, because it makes it easier to test the connectivity between the input and the output connectors through the relays with a continuity tester like a multimeter. A lot easier than if the sockets were there. I will put the sockets on, but for now I'm ready to test it to make sure that the thing actually works. Okay, it's hooked up to the amplifier, so all I've got to do is just turn the amp on. I did hear a click over here. Well, what do you know? It works. Okay, so let's test the connectivity between each input and the output. Now, goes this way. The right is on the right and the left is in the left position on the sockets. So first I'll check I've got a ground, which is the center. Yep, that should be coming out the right. It is. That should be coming out the left. It is. It's not coming out the right anymore. Good. Next one. Should be nothing on the first one. Nope. Second one. Yes. Yes. Third one. Yes. Yes. Final one. Yes. Yes. Well, hallelujah.
You won!
So the next things I've got to do is I've got to pop the RCA sockets on there, and I've also got to pop the rear panel back off and mark and drill out the holes to accept the said RCA sockets. And apart from the power cord grip and the fuse holder holes at the other side of the case here, that's pretty much the back panel drilled. I do have the pilot holes for the first two aforementioned holes, but I just haven't sized them out yet. I don't know whether I'm going to do that today or not, but I am definitely going to drill out my holes for my RCA sockets and its mounting holes, and hopefully everything lines up. Alright, the sockets are on and the holes are marked out ready for drilling. I haven't center punched them yet. I've come in 10mm from the top just to give the bottom area where the PCB is a little bit more clearance from the bottom of the case, because it is very close. So it's not directly in the center is what I'm trying to say. But if I bring the board up to where my lines are marked, it almost lines up perfectly. My measurements are pretty close. Same as if I went sideways. I don't know if you can see that on camera, but yeah, it'll line up just fine. So now all I've got to do is center punch these holes, drill them, which is going to be fun, because these 8 holes here have to be sized up to, I believe it's 10mm. I don't know if I can actually fit the RCA sockets through these speaker holes. And even 10mm is a bit tight. I believe that's 10mm. I'm not sure offhand. The diameter of that hole is... no, it's only like 8mm. That's why it won't fit. Okay, that's all good. So yeah, I'm going to center punch these, pilot hole drill them out, and then size them out to fit. I might make these mounting holes 3.2 or something, just to give the screw a little bit of wiggle room. Yeah, anyway, I'm going to take a break before I do that, and then I'll come back and drill it, and then I'll come back on video once I've drilled it, because I don't want to make this video too much longer because it's already going on for a million years. Alright, a short time later, there's the thing drilled. They're drilled out to 10mm. Now, it doesn't leave a lot of room for the lettering, but I can probably just put the lettering for what each input does down the bottom here. How does the board fit? So, if I take this, and it lines up almost perfectly. Look at that. That is so cool. Let me find some screws to put into here, and so I can screw the board to the back panel. These screws came out of an old Sony product, so but these will probably do the job. Let's get it started at least. See how off my measurements are, which they probably are. I mean, question is, will it mount flat? It doesn't appear to, but anyway, I'll keep going. It's only plastic, so I don't want to over tighten it, because these have got to come back off again anyway to do the labelling and spraying of the panel. So, don't want it overly tight. Just tight enough to hold it. There we go. Yeah, that doesn't look too bad. With these exposed bits of aluminium around the edges of the hole, I can always fill that in with a bit of black texture to finish it off. That one's kind of off, it's really resting up against the edge, but it'll serve the purpose. And if I can grab the RCA lead that's on the floor, see, I mean, that's all it needs to do. That's perfect. And as for mechanical strength, clearance looks good. As for mechanical strength, it's perfect. Maybe slightly crooked, but yeah. The bottom of the case is actually here anyway, so this should be plenty of clearance from the bottom of the case. So now I've got the task of putting the case back together, which is not a hard task. I mean, it only took me about probably 5 minutes to take it apart. Anyway, let me get to doing that. And there it is there, all back together. I believe everything's plugged in where it should be. Well, it's not that hard. I got some of these self-adhesive cable clip things and stuck them to the side of the case just to keep the DC wiring and the audio lead wiring neat. There's plenty of clearance between here and the bottom of the case. It's about 5mm. So I'm ready to turn this on and test it. So I'll just do that. Okay. Relay clicked. Another one clicked. Another one clicked. And the first one clicked. Right, so I guess I'll hook it up to some form of audio source and fart again for the second time in this video, and just test that all the inputs work. Yeah, okay. Oh, that stunk. Alright, I've got my oscillator going into the first input on the left at the moment. I've taken the oscillator ground and put it to the star ground. It's not an ideal place. It really should be connected to the audio ground of the sockets, but for testing purposes, just to see if the signal comes out, it's perfectly fine. The speaker's hooked up to the left channel, and all I do now is turn it on. Lovely, we've got a signal. Okay, there's going to be a bit of a pop there when you switch in and out signals. So I'll swap over to the next input. Perfect. Next input. Perfect. Perfect. Alright. So I will switch to the right channel and see if we get a signal. I need to switch this around. Yes, we do. Go to the next one. Yep. Yep. And yes. Turn it off because it's annoying. Very, very good. It is working. It is alive. It is alive. I have no idea what the hell that was. Okay. So I think that'll conclude this video here because, well, I've got a working input selector now, even though it makes a pop and a click when you're switching between channels, but I think most amplifiers that use relays do that. It's only because the signal is suddenly coming out, and it's to do with the input capacitors charging and discharging. It's just the way it is. Anyhow, I'm the Astro 30, and if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook. The links are in the description as usual, guys. Anyway, this is the Astro 30 saying, see ya, have a great day. I actually made a bad situation good. Yay!
Bye.